What's up, guys? Welcome to our third edition of Math Academy Rewind. Today we're going to be looking at systems of equations. We're going to go back and look at that. Remember, a system of equation is just when you're finding a solution that fits two equations. There were three different ways that we talked about. It was graphing, substitution, and elimination. So let's go back and look at those, starting with graphing. So when we graph to solve for systems of equations, we want our equation written in slope-intercept form. Remember, that's y equals mx plus b. We're graphing both equations, and the way the equation looks tells us our solution. If they cross each other or intersect, that's one solution. If they're parallel lines, that means they have the same slope. That's no solution. And if they're the exact same everything, that means they're infinitely many solutions. So let's look at an example here. So we have a graphing example. Again, we want it in slope-intercept form. We're going to graph both equations and look at the way it looks at the end and see if we have one solution, no solution, or many solutions. So let's start with this first equation. The first equation is already written in slope-intercept form, so I've plotted the 3 points on the graph. Our first point starts with our y-intercept at positive 3. Then we have 4x as our slope, which should be up 4, right 1. But if we notice, we'd be off the graph. So we have to flip it and go down 4, left 1, down 4, left 1. And we get these 3 points. From there, we create our line, which looks like this. The second equation, if we look, is not currently written in slope-intercept form. We want it to just have a y here, like our first equation. As you see, we have a 4x and a 4 that are in the way. So we're going to start solving this by moving our 4x to the right side to get it away. In order to do that, we're going to subtract 4x, which leaves us with 4y equals negative 8 minus 4x. From there, we need to get rid of the 4 that's with the y. We're going to do that by dividing. So I've divided everything by 4 to get y by itself. And that's left me with y equals negative 8 divided by 4 is negative 2, and negative 4 divided by 4 is negative 1, and we keep our x. Our last thing that we're going to do is switch those two numbers around to get it in slope-intercept form, which leaves us with y equals negative 1x minus 2, and then finally we're going to graph those points. So our first point would be at negative 2 on the y-axis for our y-intercept. Negative 1 is down 1, right 1. Then we can do the opposite, up 1, left 1, and we see that our lines are going to intersect. Remember, that place that they intersect is our solution. So in this case, negative 1, 1 would be our solution, and that is an example of one solution. Okay, so again, graphing, graph both equations, make sure they're in slope-intercept form, and they're going to give away what the answer is. Let's go on to substitution. For substitution, we need one equation that says y equals something or x equals something. Then we substitute in. We're going to solve, we substitute again, and then we solve again. Again, we want our answer written as an ordered pair. So let's go through these steps a little bit. Let's look over at our equation. As we can see, neither one of these equations has y equals or x equals by itself. However, I do notice that x over here does not have a coefficient. So my job is to get x by itself. So we're going to start by getting rid of this negative 2. So we move it to the other side by adding 2, which leaves us with x equals 11. Plus 2. So again, all we did was take negative 2, move it over to the other side, and now we have this first step, x equals. Everything behind the equal sign gets substituted into the other equation. So since we had x equals, we're putting all this information where our x is. So our rewritten equation would look like this, negative 7, and then again, where x is, you put everything in its place. 11 plus 2y minus 2y equals negative 13, just copying that first equation. From there, we're going to solve. Remember, we reviewed the distributive property the other day. This is just multiplying, so negative 7 times 11 and negative 7 times 2y. And then from there, we're just combining like terms. So I move my negative 77 to the right side by adding, gave me 64. I combined negative 14y and negative 2y, and that gave me negative 16y. Finally, I'm going to divide by negative 16 on both sides, and y equals negative 4. So what we have just got to is this step 3. We found x equals, we substituted in, and we solve. Now we're ready to substitute again. So we're going to take that y equals negative 4, and we're going to sub it into this second equation where y is. So as you can see, I've written it the same, x minus 2, but where this y was, I've plugged in my negative 4, and that's going to equal 11. From there, I just solve it out, and I end up with x equals 3. Remember, our final step is to write this as an ordered pair, which would be 3, negative 4. Again, that is one solution. Finally, we learned about elimination. The first step is to look if they have the same coefficient. If they do, then we're good and we can go from there. If they don't, we're going to multiply one or both equations to have them have the same coefficient. Remember, if they're the same sign, we subtract, different signs we add. Solve, substitute, solve again to get our final answer. So again, let's go through these a little bit slower. So if we look, none of our variables have the same coefficient. We have 5 and 10, 1, because it's just y, and negative 7. None of those are the same. So that takes us to multiplying. Well, I see that if I multiply the top equation by 2, it's going to make 10x, which would be even with this. So I'm going to go ahead and rewrite my equations down below after I've multiplied. So remember, I did 2 times 5x to get 10x, 2 times y to get 2y, 2 times 9 to get 18, and then I took my second equation and rewrote it down below. So we're ready for these two steps right here. Same sign, subtract, different sign, add. So we know 10x and 10x have the same sign. We're going to go ahead and subtract these, make it one big subtraction problem. So I go through and I subtract, and as I do, I notice that 10x minus 10x cancels out. 2y minus negative 7y gives me 9y, because minus and negative turns to addition. 18 minus a negative is positive again, so that's 36. Again, we talked about when we did this, be careful on your signs. This is where we can get mistaken. So be careful when we subtract a negative, it really becomes addition. So we have 9y equals 36. Finally, we divide by 9 to get y equals 4. So we have successfully gotten down to this point. We're ready to substitute back in. So we're going to take our y equals 4, substitute it back into our easiest equation, which would be the top one. So we're going to substitute it back in. That would look like this. 5x plus 4, because again, instead of y, I put 4 where y is, equals 9. From there, I solved it out. I moved my 4 to the other side by subtracting. Inverse operations told me that. 5x equals 5, and divide by 5 to get 1. Again, finally, we're going to write our answer as an ordered pair. 1, 4, 1 solution. So hopefully this helped you as a quick rewind of system of equations.